Hi and welcome to the episode 5 of AWS Certified Developer Exam Mastery series. This time I will present you a few practice exam questions related to Lambda. So let's jump in. Here we have 10 questions and let's go through them one by one. Question number 1 is this. A company uses Amazon EventBridge to invoke a Lambda function asynchronously. Occasionally the function fails due to downstream API latency. The company wants to reduce the number of retry attempts and ensure that failed events are discarded after 30 minutes. What should the developer configure? Option A. Reduce Lambda timeout to 30 minutes. The fact is, maximum Lambda timeout is only 15 minutes, and this way we cannot reduce them to 30 minutes, right? This option is incorrect. B. Configure maximum retry attempts and maximum event age in seconds. In case of asynchronous invocation, when we invoke Lambda function asynchronously, the event ends up in a queue, and Lambda then picks up that event and executes it. And there is a parameter option that defines how long the event is kept in the queue. That is the maximum event age in seconds. This way we need to configure maximum event age in seconds and maximum retry attempts to define how many times we want the Lambda function to retry our request. Okay, to the next question, number 2. An S3 bucket triggers a Lambda function that processes uploaded files. If processing fails, the company wants to store both the original event and detailed error information in another service for auditing. Which solution meets this requirement? First of all, we need to understand whether it was synchronous or asynchronous call, because in case of if a Lambda function is called asynchronously, it can send a response to a Lambda destination. And Lambda destination is something that contains both error destination and success destination. According to our scenario, we need both of them. If you look at this part, S3 bucket triggers a Lambda function. S3 always triggers Lambda function asynchronously, so we can utilize Lambda destination for that. Let's find option with Lambda destination. That is configure Lambda on failure destination, so it will contain both detailed error information and the original event will be kept in logs, for example. Okay, next question. A Lambda function is triggered by an SQS queue. The function takes 2 minutes to process each message. The SQS visibility timeout is set to 30 seconds. The system occasionally processes the same message multiple times. What is the most likely cause? Here we need to understand the life cycle of messages and how they change when producer publishes a message to SQS and consumer consumes it, and what happens in between. When queue processor, the consumer, consumes a message, it must process it and then delete from the queue. Otherwise, it will appear again after visibility timeout. If a service processes the message longer than the value of the visibility timeout is, then this message will appear again in the same queue. So the correct answer, visibility timeout is shorter than processing time. Let's go to question number 4. A Lambda function behind API gateway receives sudden traffic spikes and begins returning 429 throttling errors. The account has the default concurrency limit. Which action should the developer take first? This question validates our knowledge of basic Lambda quotas. We need to know the default concurrency limit for Lambda function. That is 1000. So the correct answer is to increase the account concurrency limit. Question number 5. A company runs a customer-facing REST API backed by Lambda. Traffic is predictable and spikes every weekday at 9 a.m. Users experience latency during this first few minutes of the spike. What is the most cost-effective solution? So we have these options. We can increase memory allocation, enable provision concurrency on schedule, use reverse concurrency, or increase batch size. When something in the question says that something is predictable and happens only at a certain time, then a scheduled action is the correct answer. So the correct answer in our case here, enable provision concurrency on a schedule. That is most cost-effective solution because we are not running functions idle if we just provision them all the time. Let's see question number 6. A Lambda function is configured inside a VPC in a subnet. It must call an external third-party API but times out. The route table includes 000/0 to Internet Gateway. Why is the function timing out? If the function is deployed in a subnet with this routing rule, it means that in theory function is capable of connecting to anything in the outside world on the internet, right? It doesn't connect because of security group rules or because of misconfigurations in subnet network access rules. So the correct answer here is D. We need to check security group and subnet NACLs. We have to make sure that they allow outbound traffic. And question 7. A Lambda function processes messages from an SQS queue. Occasionally duplicate processing occurs. What is the best architectural approach to prevent issues caused by duplicates? What we are dealing here is SQS queue, and that is the standard SQS queue. There is also another type, FIFO SQS queues. Standard SQS queues, they do not guarantee the order of messages, and they do not guarantee that the same message is delivered exactly once. So the correct answer is to implement idempotent logic in the function. It means that if we have a duplicate message, the internal logic of the consumer is aware that we already had this message and doesn't insert another entry in a database, for example. Question 8. A mobile application sends 8 MB images directly to Lambda function synchronously via API gateway. The requests fail intermittently. What is the best solution? First thing that we must pay attention to is what type of invocation it was. We can see that it was synchronous invocation. And another important thing to remember is the payload sizes for synchronous and asynchronous invocations of Lambda functions. They are different. As far as synchronous invocation, the limit there is 6 MB. We have 8. That is the reason why the Lambda is failing. And what we can do here is described in option C. We can keep the image in S3 and pass an object key to Lambda. So the mobile application first uploads the image to S3 and then reports only the image S3 URL to Lambda function. And question 9. A Lambda function writes order records into DynamoDB. It is triggered by SQS. Occasionally, duplicate records appear in the database. What is the best solution? That is very similar to what we already saw in one of the previous questions. Standard SQS queues, they do not support ordering, and they do not guarantee that a message is delivered only once. They do not ensure exactly once delivery. So we need to implement idempotency on the application side, and it can be done in case of DynamoDB using conditional writes. Question number 10. A developer must temporarily stop a Lambda function that is invoked asynchronously by SNS, but cannot modify SNS configuration. What is the fastest way to prevent new executions? Yeah, we can delete the function. It will certainly work, but it is pretty destructive actions, and we're not aware if a developer has permissions to deploy another function, right? We can remove the execution role. It basically has the same effect that deleting the function, but we're not sure that we can deploy it later. What we can do is set the reserved concurrency to 0. That is the least destructive action that we can implement here. We're setting reserved concurrency to 0, and this way asynchronous functions will deliver events to dead letter queues and will error out. That was it. Thank you for being here. If you liked the video, click the like button, subscribe to the channel for future videos. See you next time. Bye.